Welcome to qnawire.
Hi friends, the enthalpy and entropy at state 1 for temperature minus 10 degrees Celsius with saturated vapor from table A11. H1 is 244.55 kilojoule per kg and entropy to be 0.93782 kilojoule per kg per Kelvin. The isentropic enthalpy at state 2 is for condition S1 is equal to S2 and P2 is equal to 450 kilopascal is 261 kilojoule per kg. Actual enthalpy will be H1 plus H2S minus H1 upon efficiency of Carnot cycle, that is 244.55 plus 261 minus 244.55 upon 0.86. So actual enthalpy you will get 263.68 kilojoule per kg. The enthalpy at state 3 for pressure 450 kilopascal and saturated liquid H3 you will get 257.58 kilojoule per kg. The enthalpy at 5 and 6 for pressure 16,000 kilopascal and saturated liquid H5 is equal to H6 135.96 kilojoule per kg. The enthalpy at 7 and 8 for pressure 450 kilopascal and saturated liquid H7 is equal to H8 68.8 kilojoule per kg. Part A mass flow rate through the high pressure compressor. First, the quality of mixture at state 6, H6 minus H liquid at 450 pressure upon H evaporator 450. Substitute the value. So quality of mixture you will get 135.96 minus 68.8 upon 188.78. So it is to be 0.356. Now we can calculate the mass flow rate from state 1 to 2 upon 1 minus q, that is 0.11 upon 1 minus 0.356. So it is to be 0.171 kg per second. Now part B. Enthalpy at state 9 will be mass flow rate from 1 to 2 into H2. Mass flow rate at state third is equal to mass flow rate in 9 to 4 into H9. So H9 you will get mass flow rate from 1 to 2 into H2 plus mass flow rate from 9 to 4 state, mass flow rate 1 to 2 into H3 upon mass flow rate from 9 to 4. Substituting the value, all the values given above, so you will get 261.5 kilojoule per kg. Entropy at state 9 will be 0.9396 kilojoule per kg per Kelvin at pressure 450 kilopascal. The isentropic enthalpy at state 4 for pressure 1600 kilopascal and S4 is equal to S9. H4S you will get 288.54 kilojoule per kg. Actual enthalpy at state 4 H4 you will get H9 plus H4S minus H9 upon efficiency of Carnot cycle, that is 261.5 plus 288.54 minus 261.5 upon 0.86. So it is to be 292.94 kilojoule per kg. Rate of refrigeration is mass flow rate from 1 to 2 H1 minus H8. Substitute the value 0.171 into 244.55 minus 68.8. It is to be 19.33 kilowatt. So this is the rate of refrigeration. C part. Coefficient of performance. Rate of refrigeration upon power input. That is mass flow rate from 1 to 2 into H2 minus H1 plus mass flow rate 9 to 4 H4 minus H9. Substitute the value 19.33 upon 0.11, 263.68 minus 244.55, 0.171 into 292.94 minus 261.5. So it is to be 2.58. Now part D. Enthalpy and entropy state 1 at temperature minus 10. So H1 already we have discussed 244.55 kilojoule per kg and entropy to be 0.93782 kilojoule per kg per Kelvin. Isentropic enthalpy in state 2 will be 287.94 kilojoule per kg at pressure 1600 kilopascal and S2 is equal to S1. So H2 actual will be H2 equal to H1 plus H2S minus H1 upon efficiency of Carnot cycle. Substitute the value 244.55 plus 287.94 minus 244.55 upon 0.86. So it is equal to 295 kilojoule per kg. Enthalpy in third and fourth state. H3 is equal to H4 135.96 kilojoule per kg for pressure 1600 kilopascal and saturated liquid. So cooling load will be mass flow rate into H1 minus H4 0.171 into 244.55 minus 135.96. So it is equal to 18.57 kilowatt. And coefficient of performance, cooling rate upon power input, that is mass flow rate into H2 minus H1. Now substitute the value 18.57 divided by 0.171 into 295.244.55. So it is to be 2.15. That's all. Thanks for watching it.